we are here at OFC with EULITHA. So we are going to talk to Kelsey. Kelsey, tell us what is EULITHA and who are you?
Yes, thank you. EULITHA is a lithography equipment provider, and we specialize in a type of optical lithography that is a mask-based interference that creates really high quality, highly reliable periodic nanostructures down to UV and DUV wavelengths. So a minimum pitch of 120 to 100 nanometers of periodic nanostructures is what we can print. And so there's a lot of photonic applications where customers need that type of resolution, reliability, and the cost advantages that our tools offer. We've got some interesting pieces here. One of the main advantages of our type of lithography is that we don't have a reduction optics, magnification optics, which mean that our exposure fields match the active area of the masks that are being used. So in a standard semiconductor application, you use a 6-inch mask, a 6-inch projection reticle mask, and that ends up being about 5.5 inches of active area. So for our tools, we don't have a reduction. We keep that full field exposure. You seamlessly print in under a minute all of the devices that are patterned on that mask in that large field. So what that looks like for you guys, if you look at this 8-inch wafer back here, all of that is printed in the single exposure. So it's seamless within that 5.5-inch area. So these 6-inch wafers, here's an augmented reality waveguide, all printed under a minute, all of those devices.
Just in once.
That's right.
Wow.
What's also really cool about that is because it's all mask locked, you get almost perfect pitch. We have a test report done by OptoFidelity, who's one of our collaborators, that EULITHA's strategy has pitch uniformity that's sub 10 picometers across that exposure field. So over those 5.5 inches, sub 10 picometers of pitch accuracy. And so that's excellent for our laser customers and other applications where having really consistent pitch is extremely important to the performance of the device.
Yeah, absolutely. So, and how do you do the metrology for all your products?
Yeah, so it depends on what sort of metrology you're looking for. If you're looking for the performance of a AR waveguide, for example, the electrodiffractometer would do really well. If you're looking for other types, you got your AFMs, you've got your CDSEMs, typical semiconductor lithography.
So tell me, what is this?
Yeah, so this is really exciting. I'd like to show this to you. So this is a augmented reality waveguide demonstration that's showcasing EULITHA's lithography technology put into a full device. And so what we have here, for those that aren't familiar with augmented reality, are 2 waveguides that are patterned on special glass, special transparent substrate, and have nanostructures on that that create the waveguide. So you have in-couple, out-couple gratings on a device. And so if you pick this up and put it to your face like a pair of glasses.
With my glasses
you can
on?
put them right in front. That's okay, yeah. Because they don't have to go right to your head.
Whoa!
Yeah. So
This is,
if you get it a little bit closer, you can really see the field of view. So efficiency, the brightness of the display, the contrast of the display are all important factors that showcase that the lithography is really accurate and has a really good design.
Cool. Yeah, it's very cool. I mean, if you guys can look through here, you will see how very good resolution, the tridimensional sense is very well done. There is no sense of movements or no dizziness or anything. So it's really accurate. It's very nice, yes.
Another thing I want to show you that's really cool is these 2 optical elements that we've got in the front of our case here. So these have a anti-reflection coating on them that's sub-micron in pitch, so very high resolution. But what's interesting is that these optical elements, these lenses, have large degrees of curvature in the surface, so several millimeters of curvature. And what that showcases really well is that our tools have an extremely large depth of focus. So in typical optical lithography, your depth of focus is limited to only a couple hundred nanometers. So you need to have very flat substrates in order for the optical lithography to work. But because ours is mask-based interference lithography, we actually create a three-dimensional interference pattern that sits between the mask and the wafer, and all of that area patterns with the same resolution, the same contrast, same capability. So you're able to print on non-planar substrates, substrates that struggle with TTV, topography. It does very, very well.
That's impressive, and that actually make a big difference compared to other companies, to other manufacturers. So that's actually very, 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 very nice. What materials are you able to work
to
in?
pattern on? Anything.
Anything?
Anything
is broad.
But all of the alternate substrates, so non-silicon substrates, everything that's been thrown at us, we've been able to pattern. Our technology is agnostic to the substrate itself. We also pattern on very thick substrates. And like you see here, you know, non-planar substrates is no problem. We've even gotten metal plates as substrates, and we're able to pattern on those as well.
Okay, so we have been talking about what you can do for others, but as the Optica question, what others can do for you?
Well, we're always looking for new applications and new ways that this lithography could be a cost and manufacturing benefit for customers out there. So we're always just trying to educate the industry as much as we can that this is a really exciting innovation in the world of lithography, especially in the photonics world of lithography, where cost is so important. You have the alternate substrates, you know, gallium arsenide, indium phosphide substrates, high refractive index glasses, silicon carbide. You know, that we're a very manufacturable and cost-effective solution for that. So finding those perfect applications is why we're here today.